In this video, I'm going to teach you how to do metric conversions without doing any math. And that's the nice thing about the metric system, is because it's based on units of 10, you don't actually have to do math to be able to convert from one unit to another. Now, here in the United States, we use the imperial system with inches, feet, yards. And those are units of measurements that were based upon the size of human hands, human feet, human arms, human thumbs. And while that might have been a convenient system in a time that predated measuring devices, the system's kind of difficult to use now because you do have to use a lot of math. I mean, there's 12 inches in a foot. So if you have 5 feet, you have to do some multiplication in your head to figure out how many inches you have. And then there's 5,280 feet in a mile. So if you have, 13 miles, you have to do even more complicated math to figure out how many feet you have. Now, the metric system is much easier than that. So first of all, let's talk about the different kinds of units that we use to measure different kinds of things. So in the metric system, if we're measuring volume, we will use liters. And we use a capital L to abbreviate liters. So volume is, like if you're measuring something in the three-dimensional space that something takes up. So for example, liquids, you don't measure the height of a liquid, right? Like if you're cooking, you measure using cups. Cups is a volume measurement in the imperial system, but here we're going to use liters. If you're measuring length or height, you're going to use meters. We abbreviate that with the letter M. And if you're measuring the mass of something, then you measure in grams. Mass is a measurement on a scale. You have to use a scale or a balance to measure it. It's similar to weight. And we abbreviate grams with the letter G. So one nice thing about metric units is that whether you're measuring the volume of something, the length of something, or its mass, you have the same prefixes to the units. And then you would just attach it to liters, meters, or grams. So for example, you can have a kiloliter, a kilometer, or a kilogram. So now let's talk about the different metric units. So, we just like in the imperial system, there are units for very small measurements and units for very large measurements. So if you think about length in the imperial system, you have inches, which is a smaller measurement, and then you have yards or miles for larger measurements. So there's the same sort of thing in the metric system. Now, to remember all of the units, I have a mnemonic device. There's many out there, but this is the one I use. Kangaroos, hopping, down, big, driveways, carrying, M&Ms. And this stands for kilo, hecto, deca. And now the B stands for base, and that's your base unit. That's going to be liters, meters, or grams. So base, and that's going to be either L, M, or G. And then the next D is for deci, centi, milli, and this is where it gets tricky, milli, and then there's 2 unnamed units, and then micro. Kilo, hecto, deca, then your base, which is going to be, depending on what kind of thing you're measuring, volume, length, mass, it'll be liters, meters, or grams. Deci, centi, milli, then there's 2 unnamed units, and then micro. So whenever doing metric conversions, it's useful to remember a mnemonic device like this one and use it to write down the list of metric units in order. In this list, the largest units are on the left, kilo, and the smallest units are on the right, micro. So I would just use this list in my head to write kangaroos, hopping, down, big, driveways, carrying, M, and M's. And micro is usually written with a Greek mu. That's a Greek version of an M. So that looks like what I'm drawing there, just to distinguish it from milli. So when you're first learning to do metric conversions, you should write out all these letters, all the letters for each of the units in the correct order before you begin. And I'll show you why. So let's take an example of a metric conversion. So let's say I live 23 kilometers from my friend's house. And I would like to know how many meters that is. So my friend lives 23 kilometers or kilometers away. How many meters away does she live? So this is a typical example of a metric conversion problem. So I have to convert 23 kilometers to meters. So the way I'm going to start is to write out that list of metric units: kangaroos hopping down big driveways carrying M and M's. Now I'm going to circle the unit where I'm starting. And I'm starting with the unit that I already know. I already know the value for it. So what do I already know? 23 kilometers. So that means I'm starting at kilometers. Now I'm telling you, we're not going to do any math here. So I'll show you, we can do these metric conversions without any math. So you have 23 kilometers, so you're going to start at the K. And then where do you want to go? What do you want to find out? We want to find out meters. So meters is the base, because remember the base stands for meters, grams, liters, right? Whatever the base unit is of the kind, we're measuring distance here. So meters is the base unit for distance or length. All right, so we are starting at kilometers, and what we want to know, what we want our answer in, is in meters. So we're going 2 meters. How many times do I have to jump? We've got to jump 1, 2, 3 places. Meters is 3 units away from kilometers. So I had to jump 1, 2, 3 units to the right. So that's the number of jumps, and that's the direction of the jumps. We need both those pieces of information. All right, now we take the number that we started with, 23. I jumped to get from kilometers to meters in my letter list. I jumped 3 to the right. I'm going to make the decimal point do the same thing. So 1, 2, 3 jumps to the right. I just fill in the zeros. These zeros are just implied. We don't write, there's zeros to infinity, extending to infinity on either side of every number. We don't draw them because you can't write an infinite number of zeros. We just know that they're there, okay? But if you need to put the decimal point over here, just know that it's jumping over zeros that were there. So here's our decimal point, 1, 2, 3 to the right, okay? So now our new number is 23,000, and that's the meters. We jumped from kilometers to meters, okay? We jumped from 23 kilometers to 23,000 meters. That means that there are 23,000 meters in 23 kilometers. And the reason is that kilometers is 3 orders of magnitude bigger than meters. In this list of units, in this letter list of units, each unit is 1 order of magnitude different from the unit next to it. So if we start at the smallest, let me get a different color here. If we were to start at the smallest at micro, micro is 10 times smaller than this unit that's unnamed, which is 10 times smaller than this one, which is 10 times smaller than this one, which is 10 times smaller than this one. So each unit is 10 times bigger than the one next to it on the one side, and 10 times smaller than the one next to it on the other side. And every time you multiply or divide by 10, all you're doing is moving a decimal point to the right or to the left, depending on whether you're getting bigger or getting smaller. Let's say I'm working in a lab and I have to use a micropipette to pipette chemicals, maybe for a DNA extraction or something like that. So we're working with very small quantities of liquid. So when we work with liquids, we are working with volume, that's liters, okay? So let's say I have 500 microliters, so that's a Greek mu for micro, 500 microliters of solution. How many milliliters is that? So again, we're going to write our list of units. Kangaroos hopping down big driveways carrying M and M's. Now, in this example, you're going to see why it's important to remember that there are 2 unnamed units here. Because remember, we're counting jumps to figure out how far to move our decimal point, right or left. If you don't have both of those blanks in there, you're not going to count the correct number of jumps and you'll get the wrong answer. So we're starting with microliters here. So here, let me go to red again. Starting with microliters because that's what I know. You always start with what you know and you go to what you're trying to figure out. So what I'm trying to figure out is milliliters. Milliliters, so that's that M. So again, we're going to count the jumps and pay attention to the direction. So here we're going to count 1, 2, 3. It's 3 because there's 2 blank spaces here. So 1, 2, 3. And this time, which direction did I move? Left. So this is different than the last example. I jumped 3 to the left. That means my decimal point is going to travel 3 to the left. So my original number was 500.0, repeating, of course. Now it's going to jump 3 to the left. 1, 2, 3. It's going to end up there. So that's going to equal 0.5 milliliters. 500 microliters equals 0.5 milliliters. Let's say we want to know how much a tear weighs. So we capture a tear and we weigh it. And we find that it weighs 0.05 grams. Now, in reality, grams are a measure of mass, not of weight. The two things are slightly different, but I'm going to use them interchangeably for simplicity's sake because we're going to measure both of them with a scale. So my tear weighs 0.05 grams, and I would like to know how many decigrams it weighs. So again, write out your string of letters for the string of units in the correct order. And again, for me, it's kangaroos hopping down big driveways carrying M and M's. And base is liters, grams, or meters. That's the base unit for volume, mass, and length. So I'm starting with grams. That's where I'm starting, right? And what am I moving to? I'm moving towards decigrams. This one's a little confusing because you have 2 Ds. Deca for the first D on the left, and deci for the second D, the one on the right. We're going to move, so this is where we're trying to go to. This is only 1 jump away. 1 jump to the right. That means my decimal point is going to move 1 to the right. So let me rewrite my number and follow the decimal point, moving 1 to the right. So now we're going to place it there. So now we have 0.5, and that's going to be decigrams. Now this means that 0.5 decigrams is equal to 0.05 grams. In the same way that there are 12 inches in a foot. You have 12 inches and you have a foot. They're the same length, right? It's the same value. Now what I find students get tripped up on the most is figuring out which direction to jump the decimal point. Even if you're writing out this list of letters, I find that sometimes students forget where they're supposed to start and where they're supposed to end, and so they might do it backwards, and then they move their decimal point backwards from how it's supposed to move. Now, one way you can check your work to make sure that hasn't happened to you is to think about whether you expect the number in your answer to be bigger or smaller than the number in your question. And that's a little counterintuitive to think about because the unit that is bigger should actually have a smaller number associated with it. And I have a way to make that intuitive for you. So you're familiar with rulers and feet and inches, and you know that there are 12 inches in a foot. So you can say 12 inches equals 1 foot. Which unit is bigger, inches or feet? Feet are bigger than inches, right? An inch is like that and a foot's like that. So feet are bigger. But in this equivalency equation that I just wrote, there's only 1 foot and there's 12 inches. So 12 is a bigger number than 1. So inches is the smaller unit, but it has the bigger number associated with it. Feet is the bigger unit and it has the smaller number associated with it. Why? Because this is an equivalency. It's the same distance, just written in a different way. And when you've written it in feet, you've divided that distance into larger segments, into 1 segment, in fact. And when you're dividing that length into inches, you're dividing it into tiny segments. More small things can fit into that distance than large things, right? So it's the same thing with metric units. So in this metric a conversion that I just did here. Decigrams is smaller and grams is larger. So it has the smaller number. So the larger unit has the smaller number. The smaller unit has the larger number. You end up with this equivalency, right? Where you have, 0.5 decigrams equals 0.05 grams. Make sure that the larger unit has the smaller number attached to it. Before I finish, I just want to reiterate that point one last time here. So here we had 23,000 meters equals 23 kilometers. And this is, by the way, meters is M, kilometers is km. So meters is the smaller unit. Meters are smaller than kilometers. So they have the larger number attached, right? 23,000 is bigger than 23. Kilometers is the larger unit, so it has the smaller number attached. All right, and that's how you do metric conversions with zero math.